It is a common situation to need to repeat execution of the same code many times. We already covered one way to repeat code via array methods. The forEach, map, and reduce methods all repeatedly run the callback passed to it once for each element of the array. If the goal is to repeatedly run code not associated with an array, then we need some other techniques. The for loop is useful for repeatedly running a block of code a specific number of times. This code outputs the numbers 0 through 4 to the console, with each number on a different line. The for loop consists of several parts. The first part is the for keyword. This is followed by parentheses. Inside these parentheses, there are 3 parts separated by semicolons. The first part is used to initialize a variable that is typically a counter for the number of iterations. The second part is a Boolean expression that determines if the code belonging to the loop will run. The value of this expression must be true for the code to run. The third part inside the parentheses is typically used for modifying the value of the counter. After the parentheses, we have braces which demarcate the beginning and the end of the code block that belongs to the loop. It is this code that gets repeatedly run, and this part of the for loop is known as its body. An important point to be aware of is the order of initialization, testing, and adjusting the counter. The initialization happens only once. The test is performed right before each execution of the code in the body. The adjustment to the value of the counter happens after the code in the body has been executed. In this example, the initial value of I is 0 and 0 is less than 5, so the code in the body of the loop will run. After that code runs, the value of I is incremented by 1. The test of I less than 5 is then run with the new value, which is 1 on the second iteration, and 1 is less than 5, so the body of the loop runs again, and that outputs the 1 to the console. After that, the value of I is incremented to 2 and tested to determine if it is less than 5, which it is, so the console log runs again. This cycle repeats until I has a value of 5. Although the value of I actually becomes 5 at the end, the body of the loop doesn't run again, so the console log, which is contained in the body, doesn't execute for this final value of I. It is possible to write a for loop in which the body never runs. For example, changing the condition to I greater than 1 will cause the body to never run because the initial value of 0 is not greater than 1. Although repeatedly incrementing the value of I will eventually make it greater than 1, that never happens. The false value of this condition stops all further iterations of the loop, and the value of I only increments after each iteration of the loop. Note that the scope of the counter is the same as if it was declared inside the body of the loop. Because using let to declare a variable makes it block scoped, the value of I is not accessible outside the loop. If we change the let to var, the value of I is accessible because that makes it function scoped. The most common for loops increment or decrement a counter by 1, but that is not a requirement. Here's an example of incrementing by 2. This code outputs even numbers from 0 to 8. Here's an example of counting backwards from 10 down to 0. Notice that the condition being tested is if I is greater than or equal to 0. When I reaches -1, that will be not greater than or equal to 0, so the loop stops running. It is also possible for the condition being tested to not involve the counter. However, this is uncommon and it may be considered bad practice because there are other ways to create loops that don't rely on a specific number of iterations. The for loop is usually chosen specifically because it can control a specific number of iterations, and that is done by checking the value of the counter. It is also easy to see how many times the loop will run by looking at the code in between the parentheses. This is an example of code using a for loop that runs a random number of times. We will cover a better way to do this later, just be aware that this is considered to be bad practice. Also note that the counter doesn't have to be used in the body of the loop. It can just be used for the sole purpose of controlling the number of iterations. This code outputs hello world 5 times. There are times when you might want to skip running the body of the loop for specific iterations without terminating the loop entirely. The continue keyword can be used for this purpose. This code outputs the numbers 0, 1, 3, and 4, skipping 2. Note that continue causes the next iteration of the loop to begin immediately without running the rest of the body of the loop. That means placing continue at the end of the body of the loop has no effect. This rearrangement of the code causes the console log of 2 to not be skipped. We can even remove the if statement and unconditionally continue without changing the behavior of this program, because the continue is the last statement, so it does nothing. If you want to completely terminate a loop and not just skip a specific iteration, you can use the break keyword. This code only outputs 0, 1, and 2. When the value of I reaches 3, the break runs and that terminates the loop. This simplified example could have been easily rewritten without using a break just by changing the loop condition to test if I is less than 3. However, there is a fundamental difference in that the loop condition is only tested at the start of an iteration. The break can be used anywhere inside the body of the loop, so a test that triggers it can happen in other parts besides the top of the loop body. This code outputs 00112. Notice that the 2 is only logged once and not twice because the second console log in the code comes after the break. Trying to write this code without the break does not produce the same outcome. This version of the code doesn't output the 2 at all. If I change the loop condition to test for I less than 3, the 2 is logged, but it is logged twice instead of once. The second log can't be stopped this way because the loop condition is only tested at the start and not in the middle. Using break allows you to make the decision to terminate at any point in the loop's body. It is important to understand how for loops affect the flow of execution. In the absence of a continue or break, the entire body of the loop repeatedly executes until the loop condition is false. No code after the loop body will execute until all iterations of the loop have completed. In this example, the console log after the loop does not run until all the console logs belonging to the loop have finished running. This principle is fairly simple but important to remember when evaluating nested loops, which are loops that are inside of other loops. This code outputs the start of the multiplication table. We can output the whole table by changing the 4s to 12s. It is only being limited in this example to let the entire output fit on the screen. In the output, observe that the number on the left of the asterisk repeats 4 times before incrementing to the next value, but the number on the right of the asterisk increments on every iteration and resets when reaching 4. It is important to understand why this happens to be able to properly understand nested loops. As I said earlier, the inner loop must complete all iterations before the outer loop proceeds to its next iteration. In this code, the values of I are incremented by the outer loop and the values of j are incremented by the inner loop. That means the values of j will cycle from 1 through 4 while the value of I doesn't change. After a complete cycle of j, I is then able to increment to the next value, and j will again cycle through all its values before I is incremented again. After I completes all its iterations, j will also not iterate again because the inner loop is part of the outer loop's body and no code belonging to that will run after the loop finishes. In general, variable names should be descriptive, but it is common practice to use the letter I for the name of the loop counter variable. In nested loops, subsequent letters are used, which is why I used I for the outer loop and j for the inner loop. In situations in which the counters are counting something specific and nameable, an appropriate name should be used. When using continue or break inside of a nested loop, that automatically applies to the level of the loop where the keyword is used. This code searches a two-dimensional array for a value of 1. Suppose we only want to find the first instance of 1, or the data is guaranteed to only have one instance. There would be no reason to continue searching after the value is found. The use of break in this code only applies to the inner loop, which is why there is only one scan in row 1, but the entirety of row 2 still gets scanned. We can add a label to the outer loop by placing an arbitrarily selected name followed immediately by a colon. We can then reference this label in the break statement by placing the label name after the break keyword. This version of the code stops scanning immediately after finding the value that we are looking for. There is no further scanning of row 1 and row 2 is never scanned. Labels are also useful when used with continue. This code scans a two-dimensional array that represents a game of tic-tac-toe looking for empty rows. When any non-empty cell is found, the scanning of the rest of that entire row is skipped. This is why only the first element of row 0 is scanned. That is not empty, so the rest of the row doesn't need to be scanned. In contrast, the entirety of row 1 has to be scanned to guarantee that none of the elements are non-empty. It is possible to make a loop that theoretically iterates forever. This is known as an infinite loop. This can happen if the loop condition never becomes false. In this example, the initial value of I is 0. The value of I is then incremented repeatedly, which never makes it less than 0. Most infinite loops should be avoided because they can cause an application to freeze or crash. As mentioned earlier, code that comes after a loop doesn't execute until the loop completes all iterations. That means code that comes after an infinite loop will never run. The application stalls at that point and can't do anything else. There is a special situation in which you might want to intentionally create an infinite loop, but we will cover that at a later time. Note that using a break can prevent the loop from being infinite. This loop iterates 6 times. In fact, the loop condition could be changed to true, and the loop would still not be infinite because of the break. The type of for loop that we covered in this session is often referred to as a traditional for loop. There are other kinds of for loops, and there are other loops that don't use the for keyword. We will continue the topic of loops in the next video.